So, good morning, dear students. Myself, Dr. Lingraju, Assistant Professor, Government First Degree College, Tumkur. So, our college is affiliated to Tumkur University. So, today we discuss in polarization of light chapter some problems. This is the last sessions of this chapter. Whatever the concepts we discussed, using that formulas, so we are going to solve some problems. So this is the BSc Physics 4th semester syllabus. So the problems are very important for acquiring good marks because they are all very short formulas and also short answers. So if you attend properly with a proper unit, proper accuracy of a result, so we can get a complete marks. So for all of you, dear students, all of you, don't neglect the problems. Concentrate along with the theory, the problems also. So attend all the problems. You can get the very good marks. So that is my part of the suggestions. So now we discuss the problems. Now here I will going to read the first problems and how it is going to calculate and explain along with the data. You see, the first problem is the polarizing angle for glass is 57 degree 24 minute. Calculate the refractive index for glass. You see how it is there, the problem. The refractive index of a glass means they are maintaining a two mediums. The light will be going to incident from one region to the other regions. So at the time, so we have to calculate the refractive index of a glass. Here the polarizing angle, the light angle will be incident at an angle of 57 degree 24 minutes. That is theta p, polarizing angle, 57 degree 24 minutes. Find the n, refractive index, according to Brewster's law. So in a Nicol prism, we are going to apply the Nicol prism. So at a Brewster's angle, the light will be gets reflected at an angle of 45 degree. So that is the concept here we are discussed through a Brewster's law. So the refractive index of the material is given by n is equal to tan theta p. So theta p is given, direct problem, direct formula is there here. So tan of 57 degree 24 minute, the refractive index is 1.54 for the glass. This is the here we are going to solve the problems. You see, it is for maybe a 5 marks problem. So if you know the concept behind this particular formula or problem, so we can easily get the idea about the variation, the how we are going to solve this problem. So with unit you have to represent all these things. Okay, here there is a unit for refractive index. And next here we come to the second problem. Plane polarized light. So after coming from a Nicol prism, so we are having a plane polarized light. This plane polarized light passes through a quartz plate with its optic axis parallel to the faces. Parallel to the faces. Calculate the least thickness of the plate for which the emergent beam, the thickness of the plate for which the emergent beam, first one is equal to plane polarized, will be plane polarized and also will be accurately polarized. So we have to find out if the least thickness of a plate which is emergent beam least thickness ಆಗಿದ್ರೆ ಅವಾಗ ಇದು plane polarized ಆಗಿರುತ್ತಾ accurate polarized ಆಗಿರುತ್ತಾ, so we have to calculate it here. Okay, so the given data is, so the refractive index of a glass, two mediums, that is Ne and also a N0, so that is 1.553 and 1.544 with a wavelength of the particular radiation is 5000 angstrom. So for circularly polarized light, the path difference is given by, so it is lambda by 4 alva quarter wave plate ge. So lambda by 4 is equal to d of ne minus n naught. So substitute the values of ne minus n naught. So we get the value of d. D is equal to 1.388 into 10 to the power of minus 5 meter. For plain polarized light, the path difference is given by, that is for a half wave plate, ಎಷ್ಟಾಗುತ್ತದೆ lambda by 2. That is lambda by 2 is equal to d of ne minus n naught. So substitute these values to get the d is equal to, so 2.777 into 10 to the power of minus 5. So this is meter. So here the unit is not there here. Okay. So d is equal to 2.777 into minus 5 meter. So like that here we are going to calculate the values of the thickness of a plate if we having a 2 refractive index of the materials with having a small thickness. So that is around the refractive index of Ne and N naught. Like that here we are going to calculate it. So next we come to the third problem. A crystal plate produces an optical path difference of 1.5 into 10 to the power of minus 7 meter. A crystal plate produces an optical path difference of 1.5 into 10 to the power of minus 7 meter between the ordinary and extraordinary vibrations. Calculate the thickness of the plate, that is the refractive index of Ne is equal to 1.544, N naught is equal to 1.554 and path difference is 1.5 to the power of minus 7. Once again I will read this problem. You see, a crystal plate produces an optical path difference. Optical path difference na adu produce ಮಾಡುತ್ತೆ ಎಷ್ಟು 1.5 into 10 to the power of minus 7. ಓಕೆನಾ. ಸೊ ಅದನ್ನ ನಾವು ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ. ಅದನ್ನ ನಾವು ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಕರೆದಿದ್ದಾಮೇಲೆ ಅವಾಗ ಅಲ್ಲಿ ಎರಡು ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದ ಮೆಟೀರಿಯಲ್ಸ್ ಇರುತ್ತೆ. ಹ್ಯಾವಿಂಗ್ ಎ ಥಿಕ್ನೆಸ್ ಎಕ್ಸ್ಟ್ರಾರ್ಡಿನರಿ ವೈಬ್ರೇಷನ್ಸ್ ಆಫ್ ಆರ್ಡಿನರಿ ಅಂಡ್ ಎಕ್ಸ್ಟ್ರಾರ್ಡಿನರಿ ವೈಬ್ರೇಷನ್ಸ್. Calculating the thickness of the plate, d value ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿದೆ ಇಲ್ಲಿ. So here given value Ne is equal to 1.544, N naught is equal to 1.554. The path difference is 1.5 into 10 to the power of minus 7 meter. Since Ne is greater than N naught, ನೋಡಿರ್ತಾ ಅಲ್ವಾ. So then it is a positive plate. ಈಗ thickness of the plate d is equal to path difference. ಎಷ್ಟು value 1.5 into 10 to the power of minus 7 divided by n into the value of refractive index of 1.554 minus 1.554 and 1.544 to get the thickness is 1.5 into 10 to the power of minus 5. So this is the way here we are going to calculate the thickness of a plate if the crystal is producing a optical path difference of these values in a ordinary and extraordinary vibrations. Ordinary and extraordinary vibrations. Okay. So knowing this concept, next year we go to the fourth problem. So here calculate the rotation of the plane of polarization in a substance of unit thickness for a light of wavelength 5890 into 10 to the power of minus 10 meter. The difference between the refractive index of light and left circularly polarized light, right and left circularly polarized light in the substance is 7 into 10 to the power 7.62 into 10 to the power of minus 7. ಇಲ್ಲಿ ನೋಡಿ ಏನು ಕೊಟ್ಟು ಕೇಳಿದರೆ ಪ್ರಾಬ್ಲಮ್. ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ rotation of the plane of polarizations. Calculate the rotation of the plane of polarization in a substance of a unit thickness for a light of wavelength 5890 into 10 to the power of minus 10 meter. ಈಗ ಲ್ಯಾಂಬ್ಡಾ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಮತ್ತೆ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದ ರೈಟ್ ಅಂಡ್ ಲೆಫ್ಟ್ ಈಸ್ ಆಲ್ಸೋ ದೇ ಆರ್ ಗಿವನ್. ಏನದು ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದ ರೈಟ್ ಅಂಡ್ ಲೆಫ್ಟ್ ಎಷ್ಟದು 7nl minus nr is equal to 7.620 minus 7. The thickness is also given. How much is d is equal to 1 meter. So after knowing this one, so we have to calculate the path difference. Sorry, phase difference. Phase difference is equal to 2 pi by lambda into path difference. Phase difference is equal to 2 pi by lambda into NL minus NR of D. Phase difference is equal to 2 pi by lambda NL into NR into D. So substituting all these values to get the answer is 0.8124 radians. So that is we are getting in the radians. We have to calculate it is make it in the form of degrees. So pi by 180 that it gives the 46.57 degree. That is the phase difference of a given problem. So it's about fourth problem. Next is fifth problem. As you see, a 0.2 meter long polarimeter. Lab ಅಲ್ಲಿ ಮಾಡ್ತೀವಲ್ವ ನಾವು polarimeter experiment use ಮಾಡ್ಕೊಂಡು polarizer analyzer. So there is a polarimeter. A 0.2 meter long polarimeter to containing a certain solution of concentration 20% produces an optical rotation of 24 degree. Find the rotation of the solutions. ಇದು ನಾವು ಈಗ ಒಂದು ಪೊಲಾರಿಮೀಟರ್ ಒಳಗಡೆ ಒಂದು ಶುಗರ್ ಸೊಲ್ಯೂಷನ್ ತಗೊಂತೀವಿ. ಅದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿರುತ್ತೆ 20% in a optical rotation of 24 degree ನಲ್ಲಿ. So find the rotation of solutions. So S ವ್ಯಾಲ್ಯೂ ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿದೆ. ಸೊ ಇಲ್ಲಿ ಏನೇನು ಗಿವನ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾನೆ. ಸೊ ಹೈ ವ್ಯಾಲ್ಯೂಸ್ ಗಿವನ್ ಎಷ್ಟು 0.2 ಅದರ ಲೆಂತ್ ಮೀಟರ್. ಸೊ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾನೆ ಅಟ್ ಅನ್ ಆಂಗಲ್ ಆಫ್ 24 ಡಿಗ್ರಿ. ಸೊ ಅದನ್ನು ನಾವು ಡಿಗ್ರಿನ ರೇಡಿಯನ್ಸಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. 24 into pi by 180 that is equal to 0.4186 radians. Next concentration C is equal to 20%. ಅದನ್ನು ನಾವು ಕಿಲೋಗ್ರಾಮಿಗೆ ಚೇಂಜಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಅದನ್ನು 20 by 100 GCM cube that is 0.2 by 20 10 to the power of minus 3 by 10 to the power of minus 6. So then C is equal to 2000 kg per meter cube ಆಗುತ್ತೆ. Then we know specific rotation formula S is equal to theta by 1 IC. So substituting all the data, theta value ಗೊತ್ತು, I value ಗೊತ್ತು, C value ಗೊತ್ತು. So we are getting S value. That is substituting given data we arrive the required solution. S is equal to 0.01046 radians per kg per meter square. Radians per kg per meter square. So like that here we are going to calculate the rotation of solutions using a polarimeter. In the experiment also lab ಅಲ್ಲಿ ಮಾಡಬೇಕಾದ್ರೆ in the experiment also we are going to calculate the polarizer and analyzers. So on what angle here we are getting a very bright light, on what angle, on what degree, so we are getting a very dark color. So we have to write it. So this to be with respect to some different concentrations of a sugar solutions. So based on that, here we are going to take the average values to calculate the S values. So find the rotation of the solutions, polarizer and analyzer. So similarly also here, theoretically here also we are going to calculate the concepts. So it's about this problem. Next is sixth problem. A beam of linearly polarized light is changed into circularly polarized light. A beam of linearly polarized light is changed into circularly polarized light by passing through a calcite crystal of thickness is 3 into 10 to the power of 15 meter. Calculate the difference in refractive indices of two ways in the crystals. The wavelength is given. Once again I will read this problem. A beam of linearly polarized light. So we are getting a one monochromatic light is already polarized. A beam of linearly polarized light is changed into circularly polarized light. ಅದು polarized light radiation circular polarization ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. Changed into circularly polarized light by passing through a crystal, calcite crystal ಒಳಗಡೆ ಮುಖಾಂತರ ಹೋಗಿದ್ದಾದ್ಮೇಲೆ ಆ ಲೀನಿಯರ್ ಪೋಲರೈಸರ್ ಲೈಟ್ ಸರ್ಕ್ಯುಲರ್ ಪೋಲರೈಸರ್ ಆಯಿತು. ಯಾವಾಗ ಅದ್ರ ಥಿಕ್ನೆಸ್ಸು 3 into 10 to the power of minus 5 ಮೀಟರ್ ಇದ್ದಾಗ ಆಗ ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿರೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡಿಸ್ ಆಫ್ ಟೂ ರೇಸ್ ಇನ್ ದ ಕ್ರಿಸ್ಟಲ್ಸ್. ಅದರೊಳಗಡೆ ಟೂ ರೇಸಸ್ ಹೋಗ್ತಾವಲ್ವಾ, ಸೊ ಆರ್ಡಿನರಿ ಅಂಡ್ ಎಕ್ಸ್ಟ್ರಾರ್ಡಿನರಿ. ಅದರದ್ದು ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟಿದೆ ಎನ್ ಇ ಮತ್ತೆ ಎನ್ ನಾಟ್ ಆರ್ಡಿನರಿ ಮತ್ತೆ ಎಕ್ಸ್ಟ್ರಾರ್ಡಿನರಿ ರೇಸ್ ಡಿಫರೆನ್ಸ್ ಆಫ್ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಎಷ್ಟಿದೆ ಅಂತ ಕಂಡುಹಿಡಿಯಬೇಕು. ಇಫ್ ದ ವೇವ್ ಲೆಂತ್ ಈಸ್ 6 × 10⁻⁷. ಸೊ ದಿಸ್ ದ ವೇ ಹಿಯರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಇಲ್ಲಿ ನೋಡಿ ಟಿ ಈಸ್ ಕೊಟ್ಟಿದ್ದಾನೆ, ಥಿಕ್ನೆಸ್ ಎಷ್ಟಿದೆ 3 × 10⁻⁵ ಮೀಟರ್. ಲ್ಯಾಂಬ್ಡಾ ಕೊಟ್ಟಿದ್ದಾರೆ 6 × 10⁻⁷ ಮೀಟರ್. ಸೊ ಟು ಫೈಂಡ್ the difference of refractive n e minus n naught. We know that the quarter wave plate converts plane polarized high into circular plane polarized light. So ಈಗ ಕ್ವಾರ್ಟರ್ ವೇವ್ ಪ್ಲೇಟ್ಗೆ ಏನು ರಿಲೇಷನ್ ಏನು, ಟಿ is equal to lambda by 4 of n e, that is refractive index of extraordinary minus extraordinary radiation. So here we have to calculate n e minus n naught. Simplify these equations towards n e minus n naught. n e minus n naught is equal to lambda by 4 into t. So on substituting of all these things, lambda value gottu, 4 value gottu, t thickness value gottu. So substituting of all these values, the difference of the refractive index of ordinary and extraordinary radiations of refractive index is 0.5 into 10 to the power of -2. So this is the way here we are going to calculate this refractive index using these formulas. Okay, so you see how much easy. If you know the basic concepts about a particular subject, particular topic, so we can easily identify what formula we require. So just here we have to analyze. So what are the data they are given? What are the things here we have to calculate it. Knowing these two things, so what is the formula here we required, we can easily get it. So after knowing this concept, so substitute the formulas and get the answers. So problems is simple problems, but if you know only the concept, otherwise we can't calculate. So far what I am telling is you should learn properly the theory concepts. So then only we can get the idea about the problems. Okay, next here we discuss the 7th problem. Plane polarized light is incident on a piece of quartz cut parallel to the optic axis. Find the least thickness for which ordinary ray and extraordinary ray combine to form a plane polar light. A simple last previous problem tarane idu. So the wavelength is 5893 × 10⁻⁻10. So ಇಲ್ಲಿ ordinary rays refractive index, extraordinary rays refractive index ಕೊಟ್ಟಿದ್ದಾರೆ. So here it is given that lambda is equal to 5890 × 10⁻10. So refractive index of extraordinary is 1.55, refractive index of ordinary is 1.54. So then ನಾವು ಏನು ಕಂಡುಹಿಡಿಯಬೇಕು, ಫಸ್ಟ್ ಟಿ ಕಂಡುಹಿಡಿಯಬೇಕು, ಆಮೇಲೆ ಟಿ1 ಕಂಡುಹಿಡಿಯಬೇಕು, ಆಮೇಲೆ ಟಿ2 ಕಂಡುಹಿಡಿಯಬೇಕು, ಟಿ3 ಕಂಡುಹಿಡಿಯಬೇಕು. ಸೊ ಹಿಯರ್ ಏನು ಕೇಳಿದ್ರು ಅಲ್ಲಿ, ಸೊ ಫೈಂಡ್ ದ ಲೀಸ್ಟ್ ಥಿಕ್ನೆಸ್ ಫಾರ್ ವಿಚ್ ಎ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್. ಎಷ್ಟು ಬರುತ್ತೆ ಲೀಸ್ಟ್ ಥಿಕ್ನೆಸ್. ವಿ ನೋ ದಟ್ ಫಾರ್ ಎ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್, ಫಾರ್ ಎಮರ್ಜೆಂಟ್ ಲೈಟ್, ಫಾರ್ ಎ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ಡ್, ಫಾರ್ ಎ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್. ಸೊ ಇನ್ ಆಲ್ ಕಂಡೀಷನ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಇಟ್. ಸೊ ಟಿ ಫಾರ್ಮುಲಾ ಏನು ಹೇಳುತ್ತೆ, ಸೊ ಮೊದಲನೇದು lambda by 2 of n e minus n naught. So n e ಗೊತ್ತು, n naught ಗೊತ್ತು, lambda ಗೊತ್ತು. So we are getting a t is 2.5. So after knowing this value, subsequent thickness of 2t, 3t, 4t, that is ನೋಡಿ 2t, 3t, 4t. ಇದಕ್ಕೆ 2t ಅಂದರೆ so 2 into this value, 3t ಅಂದರೆ 3 into this value, 4t ಅಂದರೆ 4t. ಸೊ ಲೈಕ್ ಜಸ್ಟ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡು ಹೋದ್ರೆ ನನಗೆ ಆನ್ಸರ್ ಬರ್ತಾ ಇದೆ. ನೋಡಿ ಇದಕ್ಕೆ ನಾವು 2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ಟು 2t. ಇದಕ್ಕೆ 3 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ಟು 3t. ಇದಕ್ಕೆ 4 multiply ಮಾಡಿದ್ರೆ equals to 4t. So like that here we are going to calculate the different order of a thickness of a glass plates. Okay na? Next here we come to the 8th and last problem. Determine the concentration of a sugar solution of length of 0.42 meter which produces an optical rotation of 26 degree. The specific rotation of the solution is 0.0402 radians per meter per kg. Also calculate the mass of the sugar solution dissolved in unit volume of sugar solution. So ಇಲ್ಲಿ ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಹೈ ಕೊಟ್ಟಿದ್ದಾರೆ. So high is 0.42, m is 0.42 meter, theta is 26 degree. 26 degree ನಾವು ರೇಡಿಯನ್ಸ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಇಷ್ಟು ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ s is Directly they are given 0.00402 radians per meter square per C concentration we have to calculate it. We know that theta is equal to SIC. So nani ಬೇಕಾಗಿರೋದು C is equal to theta by SI. So substitute the values. On substituting the given data as we required see this value. After knowing that we know C is equal to M by V. So the above equation we arrive at M is equal to C into V. On substituting the given data, we arrive at the required answer M is equal to 26.87 kg. So these are all the problems is enough, and also using some questions, different kinds of problems I will give today one more another way. So you just solve all the problems, you can get the same kind of a problem, and also if same type but the values will be different, like that only you can get the problems also in the exam. If you know the concept behind that particular problems, so you can easily get the full marks. Okay, so I will give so many different types of problems in future also. So I have referred some textbooks and also reference books for getting these kind of problems and also solve. So first one from the Sundarajan sir and also Subramaniam sir, and also 3 remaining sets are explained through a prescribed textbook of Tumkur University. So thank you from Dr. Lingaraju.